And the science is we do a lot of measurements. And those measurements have a certain number of digits associated with them, so that when we use those measurements in calculations, we have to keep up and organize and set up our answers so that they have a number of digits, or the number of digits that makes sense. And those are called significant digits or significant figures. Sometimes people call them significant numbers, but that's probably not the best terminology to use. Significant figures is the one, or significant digits is the ones that I use. So let's start with looking at a balance here. One of the first things is when you're using a balance like this, we need to keep things kind of neat and organized. Otherwise, you end up with a pile of twisted up cables that become really hard to untangle when you need them. So what I would like for you to do when you're working with any cables in the equipment that we use is to make sure that they are organized nice and neat. So I have these Velcro straps, and when you're done with your equipment, when you're putting it up, what I want you to do is to take and wind your cable nice and neat. And here's the neat way to do it, okay? So I put the strap on here. I just stuck it on here like this. And what I'm going to do is I'm going to take it, I'm going to wrap this cord around my hand like this. Okay? Oh, I don't want that to be stuck underneath there. All right? And then we can take this Velcro strap and just kind of snug it down so that it's nice and neat. Okay, and when you put it in the box, it's organized and it doesn't get tangled up. So on these particular balances, I also have these USB cords, and this one's been wound, but that's not really what I'd like to have. I'd like to have it wound the way I showed you. And typically, what I do is I stick this zip tie on here to hold it in place for you. So I'm going to rewind this. Okay, I'm going to take it and I'm going to wrap it around my hand again. And if you'll do this every time, then when you get ready to use them, they're really easy to get to and nothing's tangled up and you don't spend a lot of wasted time trying to untangle them. It takes a lot more time to untangle a tangled cord than it does to wrap it up nice and neat. So, all right, so that's nice and neat. Now, when we put it in the box, the storage box, it's important that these be stored so they're sitting flat on the bottom. It's okay if there's some flat things like this, these things in the bottom. That's all right. And this is just a CD that goes with it. That's fine. As long as the balance itself is sitting flat on the bottom of all that, that's okay. Then anything else that belongs in the box, just make sure it kind of goes around things. And then you put the top on it. Okay? And it's just closed up like this. Snap down in place. Move it so that, there we go, on the sides. All right, now I need to take it out again, and let's talk about a balance, how it's used, okay? So I'm going to take this cord here, and I'm going to plug it in the back, and then plug that in the wall, or in this case, it's the lab table. Front and back of the lab table will have these on here, okay? All right, so right now the balance is turned off, and it needs to be sitting flat on the tabletop, okay? Not cocked up on anything, not sitting on a tray, but flat on the tabletop. And then you press this on button here, hold it down a minute, and it'll come on. Now initially it's going to come on, it's going to say 0 after it cycles through a few things here. All right, so when you're weighing something, what you want to do is to weigh the material that you have that you're working with and not weigh the container. So this is a container you might use. It needs to be cleaned. I haven't cleaned it here, but it needs to be clean and dry before you use it. And by the way, drying out with paper towels is probably not the best thing. Paper towels, where you might not be able to see it, but it actually flakes off little tiny pieces of paper that get stuck on the inside. It contaminates things, and you don't get as good a measurement. So it's better to get it dried, and then if you need to, shake it out. There are some cloths we can use for drying it out if we need to. But the point is that it's better if it's clean and dry before you start, because then you don't contaminate your product or your reactants or whatever. So what I want to do is set it on the balance here, and you notice right now it's weighing the weight of the container. I want to weigh what's just inside of it. So if I press 0 again, or the on button again, it'll show me 0. And so what it's done is it's subtracted the weight of the container for you, so that what you put in there is only the weight of the thing you're looking at, okay? And that's really just something, it's called tearing the balance. Back years ago when we used manual balances, not electronic balances, we had to tear them in a different way. This is a lot easier with an electronic balance, okay? All right, so that's the balance. Let's take a look at graduated cylinders now. Oh, by the way, anytime you write down the measurements from a balance, you have to write down all the digits that are there. So right now it's showing a negative 10 point something. I've got it up in the air. If I set it down and leave it sitting nice and straight and everything, it says a negative, and I got some glare on the screen here a bit. You really can't see it so well. But it says what it's actually saying is a negative 9.47 or something like that. When I tilt it up, it gives you a different number. But whenever you write down the measurements, you need to write down all the numbers that are there. And if they are negative numbers, and in some labs we actually end up with negative numbers, you need to write down the fact that there are negative numbers. So make sure you write down what's actually there. And you also write down what the unit of measurement is. So if you look on the side over here, it says a little tiny g there. Make sure you're writing down that each time you don't write down 9.47, you write down 9.47 G, or grams. And if you're measuring a substance, then you need to also write down what you're measuring. Every time you write down a number that's a measurement or a calculated answer for something, you need to write down what it is you're measuring. So if I was measuring table salt, it would be 9.47 G NaCl. That's the chemical symbol for table salt. All right, now let's look at graduated cylinders. Now, graduated cylinders should always be stored with water inside. What this does is it keeps it in good condition so that it will drain properly. Otherwise, you get these little tiny little stains, if you will, of chemicals inside, and it starts to contaminate new reactants or products. It starts to affect what it does. It holds on to droplets on the inside so that when you pour out your chemical, you don't actually have the amount that you mean to be measuring. So if we store it with water, distilled water inside, it'll do a much better job of doing what it's supposed to do. So we always store it with distilled water. I put this stuff here, it's called parafilm, and we seal it up nice and tight on the top so that it keeps the water inside. It doesn't leak out and anything like that. All right. So what I'm going to do is take this off here. I'll put a new piece of parafilm and some new water inside when I'm done. I'll pour out some of the water just because I'm going to use the water that's in here for showing you some measurements here. All right. Okay, so when you're measuring something in a graduated cylinder, sometimes it's really hard to tell exactly what you're measuring. And so I've designed these little plastic cards here, or it's actually paper cards wrapped, it's covered in plastic with a black line on it. And here's how that works. If you take that black card and you lift it up like that, look at what you want to measure is this bottom of this meniscus here, okay? So let me sort of point to it. When you're looking at this curve, and whenever you're measuring a liquid that's water-based, you have a kind of curve across the top, okay? And so what you want to do is measure at the bottom of that curve, not the top of the curve. So right now, the bottom of that curve is dead on that second marking. Let's turn this just a bit here. And you can see then that we're at 23. And it's pretty much dead on, right at it, okay? And that's not so bad. That's pretty easy to measure. But let's suppose we're not dead on that exact marking. Okay, so now I have an amount of liquid. It's not dead on that marking. Okay, I'm going off the screen here a bit for you because I'm kneeling down to be able to see it. And when you're looking at a graduated cylinder and measuring what's in a graduated cylinder, you need to make sure that you're measuring, looking at it 90 degrees to vertical. So if your graduated cylinder is 90 degrees like this, you need to be exactly, it's vertical to the table. You need to be exactly 90 degrees to that. So you're looking at it not from a down angle, not from an up angle, but right on that level with that liquid. Okay, so if we're looking at the meniscus now, this card can help you actually see the bottom of the meniscus. There's a couple of ways to do that. One is you can put the black card right behind it and you can see the bottom of the meniscus a lot better. But if you move it down like this, you see how there's kind of a black curve along the meniscus? That might be even better. Okay, so if I look at it like this, I can see that what I have here is, here's 20 milliliters is right there. So that's 21, and 22 is right there. It's almost hidden, and 23 is right here. So we're kind of above 21 and not quite to 22. If I move the card down here, it's a little bit easier to see where that volume actually is. So it's not quite the 22. All right, and what we want to do is every time we're doing measurements with a graduated cylinder or anything that's an analog device. Now, an analog device is one like this where you have to actually figure out the amount of stuff inside. You don't just have numbers on the screen that shows you what it is. Those are called digital devices when they have things on the screen. So that balance I showed you earlier, that's a digital measuring device. I have a watch. That's a digital watch. It shows numbers on the screen. Your calculator is a digital. But this graduated cylinder is an analog device, and meter sticks are also analog devices. You have to figure out exactly what the measurement is. So what we want to do is to use these to the greatest precision that we possibly can. And so 21, let me put this back here behind it again. 21 here, put it on the other side of it. 21 here, all right, 20 and 21, that's not the greatest precision we can get to, and 22 is not the greatest precision. The greatest precision is to estimate where we are between 21 and 22 right here, okay, in between those two markings there. And so what we want to do is to figure out, okay, 22 is just a little bit too much, and 21 is a good deal too little. So I'm going to put the top level of this card here. There's 21 there, where my thumbnail is on the black top of that band there, and I put it right behind the 21 marking. And the 22 marking is right there. Okay, so the meniscus actually comes slightly below 22. So what I want to do is estimate where we are in between. So if this is 21, that's 22, and we're more than halfway in between 21 and 22. And so you might estimate 21.8. Anytime you're using an analog measuring device, you always estimate the measurement between the markings. Now, it is an estimate. So 21.8 is reasonable. 21.7 is reasonable, but 23 or 21.3 is not reasonable because I can clearly see it's more than halfway above 21 going to 22. So it's greater than 21.5, so 21.3 would not be reasonable, but 21.7 would. Now, your estimate may be different than somebody else's, and that's okay. What you want to do is to give me your best possible estimate, but this little card will help you with graduated cylinders and figuring out what the bottom of the meniscus is, and I keep these cards in the lab drawers for you. Okay, so I have refilled this graduated cylinder with water, with distilled water. It can't just be water from the sink now, it needs to be distilled water. And all the water in the back of the room, kind of in the middle of the back right there, all that's distilled. I've got a little still back there, and I've got some containers that contain distilled water. You also have these wash bottles at your lab table, and those should be filled with distilled water. So you can rinse things with this. It kind of takes forever to fill it up with this, but you can rinse things with distilled water with that. But now that I've got distilled water in here, I need to cover it with this parafilm, okay? It's called parafilm. Now, I keep the parafilm on the shelf right above table number 5. So when you get that, go over there. Every set of lab drawers has pairs of scissors in it. Just get a pair of scissors and cut a nice, neat square of this. When you try to rip it with your hands, it becomes a big mess. So please don't rip it with your hands. Use a pair of scissors, okay? And so we want to take, it's covered in the back with paper, and what I do is I just kind of take my thumbs and kind of twist it like this, and it makes it kind of start to peel back, and I peel that off. Now that side right there, that's the side that is sterile, okay? That's the side you want to put down against the top of the graduated cylinder, and you want to seal it up nice and tight. I push down with my hand. Okay, you can take the corners and pull it down, but you want to seal it up nice and tight so that none of the water inside evaporates out. And I wouldn't recommend this all the time, but it does keep it nice and sealed and that sort of thing. That's how you want to store it. Let's talk about this ring right here. Some of them are sort of a sponge rubber material, some are yellow, but this is called a bumper, and it's not designed for using it to help you measure. It stays at the top, so that if this were to accidentally tip over, it's less likely to break. That's what that is. It's called a bumper. So it stays at the top, and that's how you keep these stored. All right, let's talk about how to use those numbers now that we measure with, okay? So suppose that we have a measurement of volume that's 20, well, we use something like this, 22.8, I think it was, milliliters, okay? And we were measuring, in this case, water, so that's what we're measuring. So every time you're writing down a measurement, you have to have all the numbers that are involved, the units of measurement that are involved, and the species. This is called the species. It might be water, table salt, sugar, whatever the chemical formula is. I could have written H2O instead of water here. But you have to tell me what it is you're measuring, and then how you're measuring it, and what the value of that measurement is. So we have 22.8 milliliters, and let's say I were to take the mass of that. So I took the graduated cylinder empty, and I put it on the balance, and I tared the balance so that it shows 0 on that screen. Then I put the water in there, or I might put the graduated cylinder with the water in it on top of the balance and weigh it. Then remove the water, weigh the empty graduated cylinder, and subtract the empty weight from the weight it had when it had water in it, so I would get just the weight of the water. So let's just say the water weighed 21.85 grams. Okay? What we want to find is to take these two numbers and find the density. Now, density is always mass divided by volume. That's the definition of density. It is called an intensive property. Let's put it over here, intensive property. Now, you need to write down a definition of an intensive property because it's something you need to know for the next test. An intensive property is a property that does not change when you change the amount of stuff you're working with. So if I had a gallon container full of water, that would be the same density as if I had a thimble full, okay, of water. That would be an intensive property. Things that do change are called extensive properties. So these two measurements, milliliters and grams, are called extensive properties. If I change the amount of water, the mass, this number of grams, that's measuring mass, is going to change. So extensive properties are properties, and you need to write this down too. You need to know what an extensive property is. An extensive property is a property whose value will change when you change the amount of stuff. Okay? An extensive property is a property whose amount or value will change when you change the amount of stuff. So the volume would change and the mass would change, but the density, the mass divided by volume, would not change. Okay? So those two definitions you need to know. And while we're at it, these units of measurement measure different dimensions. Okay? So milliliters measures the dimension of volume. Grams measures the dimension of mass. Okay? So there's different dimensions of measurement. All right. Back to what we're doing here. Let's divide the mass by the volume to find the density. So we're going to take the mass, which is 21.85 grams of, and I'm going to put H2O this time. How about that? And I'm going to put it over the 22.8 milliliters of H2O. When we are doing division problems, and almost all the division problems are division and multiplication problems where we multiply fractions like this. In this case, we're just doing a division problem. But whether it's division or multiplication, if you have a unit of measurement that's the same on the top and the bottom, regardless of whether it's this fraction or one next to it they're multiplying, you can cancel out those units of measurement if they're the same, just like you can cancel x's and y's in algebra. We can also cancel these species. So this can cancel this because it's exactly the same on the top and bottom. Okay? Well, now we want to go about dividing this. So we want an equal sign here. I'm going to use my little inexpensive calculator, and you can use any calculator for this. You need a scientific calculator for this class. It's one of the supplies that are required for this class because you need to learn to use a calculator the way that it thinks, the way it's called syntax, it's the way it talks to you. If you don't get used to it, then when we get to the more complex stuff, your life becomes a lot harder doing the math. So I'm going to turn it on first, clear it out, and then I'm going to take that 21.85, I'm going to divide by 22.8, and it equals. And look at that really long set of numbers. Okay, let's put that down. We want to write that down. These are every step you see me doing here are things that are required in this class. So all the numbers that show up on the screen are required. You have to write those down. Now, those of you who kind of know what's going on, that those three, if we had a calculator that had more places, more space over here, you'd keep that 3 going forever. It's called a continuous, I forget, continuous something. But and the way you don't have to do this, but the way you indicate it's a continuous answer like that is to put an arrow, a line over that number that continues. But what we want to do is to round this off so that it matches the correct amount, the correct value, the correct significant number of significant digits. When you're doing any multiplication or division problem, you're going to look at all the measured numbers or calculated numbers. In this case, both these are measured. All the measured or calculated numbers in the problem, and find the one measured or calculated number in the problem with the least digits. So this number here has 4 digits. This one has 1, 2, 3 digits. This bottom number has the least digits. You're going to find the number, the measured or calculated number with the least digits. You might want to write that down because it's a rule that you need to follow anytime you're doing multiplication and division in this class. You look at when you're doing a multiplication or division problem, you look at all the numbers in the problem to identify which ones are measured or are calculated, And then of those measured or calculated numbers, identify the one with the least digits. And then your final answer needs to have that same number of digits. Now, to the left here is a 0 that I put as a kind of placekeeper. That's called a leading 0. And you need to know that if there's no non-zero digit to the right here, this is called a leading 0. Leading zeros then are not significant. So the first significant digit in this answer is this 9. Okay, so you need to know. You might want to write this down. You need to know it. It's going to be required that you know it. Leading zeros are not significant. Okay, trailing zeros, those on the right-hand side, would be significant if there's a decimal place. We haven't gotten to that yet. We don't have an example of that, but you need to know that trailing zeros, if there's a decimal place. If there's not a decimal place, it's different. But if there's a decimal place, trailing zeros are significant. Okay? Doesn't apply to this number, but just saying because we're talking about significant zeros here. So this is our first significant digit. We want to round it off to the 3 significant digits that matches this least significant or least number of digits measured or calculated number. And so this digit's significant, this one's significant, this one's significant, and all these 3s are not significant. Now, what's required is that you're going to underline all the insignificant digits. Okay, that's a requirement. You have to underline insignificant digits. And then you have to show me a mathematical operator, like a time sign, or this bar is a division sign or an equal sign. You have to show me a mathematical operator to show that you're rounding off. The mathematical operator we use to show we're rounding off is simply an arrow. I used a curved arrow. It could be a straight arrow over here, doesn't matter. And then you show me the rounded answer. So it's 0.95. And the way you round off is this digit here, this first rounded off number, if it's 5 or greater, you round this number up so it becomes a 9. If it's less than 5, you keep it the way it is. So it's 958. And we have grams and milliliters both left. So you have to keep your answer in grams per milliliter. So the density of this sample, this made-up example, this sample is 0.958 grams per milliliter. That's the way you handle significant digits in this class and in any physical science class.